From UFOs to possibly the best proof yet of life on another planet, K218b could be home to life. On April 17th of this year, NASA released data that could completely change our understanding of space. Signs of life were discovered on a distant planet with a probability of 99.7%. This planet is K218b, located 124 light-years away from us. In its atmosphere, chemical compounds were detected that on Earth are almost always associated with living organisms. Moreover, their concentration is 1,000 times higher than on our planet. If these substances are truly the result of biological activity as they are here on Earth, then right now there may not just be life out there, but a thriving ocean of biological diversity. Amazingly, everything points to K218b being a water world, a planet covered with deep oceans hiding active life that might be completely unlike anything on Earth. In 2015, the Kepler Space Telescope, having begun its K2 second light mission, scans the depths of space. Over the course of this mission, it discovers more than 1,200 distant planets. Among them, one especially captures scientists' attention, a planet with mysterious signs of potential habitability. It's almost 2.5 times larger and nearly 9 times heavier than our home planet. Scientists name it K218b. In 2017, the Spitzer telescope joins the research. It confirms that K218b is located within the habitable zone of its star, precisely where liquid water could exist on the planet's surface. Almost at the same time, a scientific observatory in Chile, using the precise HARP spectrograph, determines the planet's density, suggesting the presence of an ocean. The stakes rise. More and more signs suggest that life might exist on this planet. In 2019, the Hubble Space Telescope makes a new discovery. Water vapor is detected in K218b's atmosphere. The possibility of a deep, life-supporting ocean no longer seems like science fiction. Hope becomes tangible. In 2023, the most powerful modern telescope, the James Webb Space Telescope, comes into play. Its sensors detect something that instantly shocks scientists. Traces of a chemical compound known as dimethyl sulfide, DMS, a substance that with rare exceptions is almost always produced by living organisms on Earth, such as phytoplankton and other marine microbes. If this isn't an error, scientists may have found signs of life beyond Earth for the first time. Still, there wasn't complete certainty. There's always a chance it could simply be a mistake. The data might have been distorted, especially since the initial measurement was taken by a single instrument, the James Webb Space Telescope's near-infrared camera. And distinguishing dimethyl sulfide from, say, methane in that range is very difficult. Scientists were faced with a reasonable question. What if it was a glitch or a peculiar way the instrument operated? To check, NASA decided to conduct repeated observations using a different instrument and a different method. If both independent devices showed the same result, it would be possible to declare a real discovery. April 17, 2025. The James Webb Telescope uses a new instrument to perform a repeated detailed scan of K218b. This time, it's a camera operating in the mid-infrared range. The results are staggering. Signs of dimethyl sulfide are detected once again, and its concentration may be colossal, 1,000 times higher than on Earth. This isn't just any rare gas. Dimethyl sulfide is quite unusual. On Earth, it appears when microscopic algae like phytoplankton begin to decompose in the ocean. In the process of their decay, this gas is released, easily evaporating and rising into the atmosphere. And if you've ever walked along a seaside during windy weather, you've definitely smelled it. Dimethyl sulfide is what creates that characteristic ocean smell, impossible to confuse with anything else. But it's not just about the smell. This gas has an important property. It's very unstable in the atmosphere. It survives only for a few days, quickly destroyed by sunlight and oxygen. This means it can't just hang around. It has to be constantly replenished. And on Earth, this replenishment is almost always linked to life. That's why the discovery brought so much to the scientific community. The concentration of dimethyl sulfide in K218b's atmosphere turned out to be 1,000 times higher than on Earth. What could this mean? Given how quickly this gas disappears, there's only one logical explanation. If its source is biological as it is on Earth, there must be something alive on K218b, and on a huge scale, enough to constantly sustain such a large amount of dimethyl sulfide in the atmosphere. Detecting this gas from 124 light-years away sounds almost like science fiction, but the James Webb Telescope made it a reality using a truly impressive method. Every time K2-18b passes in front of its star, part of the star's light filters through the planet's atmosphere. And although it's a tiny fraction of a light, it carries a wealth of information. The atmosphere acts like a filter, absorbing specific wavelengths of light depending on what gases are present. These changes in the light spectrum are like clues left by the planet itself, which the telescope captures and sends back to Earth. Astronomers collect these clues, analyze them, and use them to reconstruct the chemical composition of the atmosphere. In other words, we're basically reading the atmosphere of a distant planet via the light of its star. But to accurately understand what K2-18b may conceal, we need to look at the conditions in which it exists. The planet orbits the star K2-18, a cool red dwarf located 124 light-years away from Earth. Its orbit lies very close to the star, about 2.5 times closer than Mercury is to the Sun. However, the star itself is much smaller, cooler, and dimmer than our Sun. Thanks to this delicate cosmic balance, K2-18b receives approximately the same amount of heat and light as Earth. That's why it's considered potentially habitable. Scientists classify it as a so-called Hycean planet, a hypothetical exoplanet proposed in 2021, which could be completely covered by a deep ocean and hidden beneath a thick hydrogen-rich atmosphere. Additionally, it was determined that there is no ammonia in K2-18b's atmosphere, which also support the idea that there may be a vast amount of water on the surface. Ammonia would simply dissolve into the ocean. But despite all these promising signs, there are serious doubts as well. If the planet is really encased in water, it might be too hot. So hot, in fact, that life as we know it simply couldn't exist. The temperature, pressure, and chemical environment could turn the ocean into a boiling inferno. Moreover, there's still an active debate about the true nature of the planet itself. Some scientists, including Dr. Nicholas Vaughan of NASA's AES Research Center, believe that K2-18b might not be an ocean world at all, but rather a miniature gas giant without a solid surface. If that's the case, the chances of life on this planet will almost completely vanish. However, the project's lead researcher, Professor Niku Madhusudhan from the University of Cambridge Institute of Astronomy, views the situation with much greater optimism. It was his team that discovered signs of dimethyl sulfide, and is convinced that K2-18b does indeed have an ocean and could be teeming with life. According to him, in the next 1 to 2 years, scientists will be able to determine with 100% accuracy whether this gas is present and whether it's a product of biological processes or has some other origin. Currently, scientists estimate the probability of signs of potential life in K2-18b's atmosphere at an impressive 99.7%. This is the highest level of reliability ever recorded in the search for biosignatures beyond Earth. In scientific statistics, this level of probable accuracy is referenced to as 3 sigma out of 5, meaning the confidence level is about 99.7%. For reference, during initial observations, possible signs of biological activity were detected with only 1 sigma confidence, about 68%. But for a claim to be considered absolutely reliable by scientific standards, it needs to reach 5 sigma, 99.9994% confidence, or just 1 chance in a million that the scientists are wrong. This 5 sigma threshold was, for example, the standard required for the discovery of the Higgs boson in 2012. And the same level of precision is now expected from the data on K2-18b. No matter how promising it all sounds, scientists at the University of Cambridge are proceeding with caution. It's still too early to declare sensation. To confidently claim the existence of life on K2-18b, researchers must first confirm the presence of dimethyl sulfide in its atmosphere with 99.9994% certainty. Then, they must prove that this gas indeed has a biological origin, similar to how it's produced on Earth. If this is confirmed, we would witness something truly extraordinary, the first real proof of extraterrestrial life in history. But what's even more astounding is not just the fact of its existence, but the place where it might be found. K2-18b is located just 124 light-years away from Earth, or about 730 trillion miles. For us humans, that distance seems absolutely insurmountable. Even trying to send a person to Mars remains a huge challenge, not to mention interstellar travel, which might forever remain beyond our reach. However, When looking at the scale of the universe itself, a distance of 124 light-years is not just small, it's barely a speck on the map. The universe stretches across 93 billion light-years. And if life is found on a planet just 124 light-years away, it would be like saying, ocean floor's organisms might navigate by detecting vibrations, heat, magnetic fields, or chemical signals. Some could even develop bioluminescence, the ability to produce light, like Earth's fireflies or anglerfish. But what's especially interesting is the potential size of such creatures. In a hydrogen atmosphere, where the medium's density is lower than Earth's, organisms could have advantages for growth. Hydrogen is lighter than air, meaning the buoyant force would be greater. This could lead to the development of much larger creatures than those found on Earth. Perhaps they'd be slow-moving, with massive bodies adapted to high pressure and dense water, something like giant jellyfish or amorphous beings drifting through the warm ocean depths, or perhaps even floating within the atmosphere itself. Moreover, adaptation to colossal pressure would likely be a key feature of these beings. The ocean on K218b could be significantly deeper than Earth's, and it's quite possible that if diverse life exists, some of its representatives could comfortably live at depths of 10 to 15 miles, where the pressure could reach between 1,600 and 2,400 atmospheres, far exceeding the pressure of the deepest known point on Earth, the Mariana Trench. To survive under such extreme conditions, animals on K218b might possess bodies capable of withstanding immense pressure. The first thing that comes to mind is the development of a strong yet flexible outer shell that protects internal organs from pressure. These creatures might have dense, almost cartilaginous or skeletal structures made of tough biopolymers several times stronger than those found in Earth's organisms. Imagine animals with an external skeleton covered in a special material capable not only of withstanding high pressure, but also of mitigating its impact on internal tissues. These structures could resemble the frameworks of exoskeletal organisms such as crabs, but several times denser and far more resistant to deformation. Their bodies might be covered with tough biological scales or an armor that is both flexible and strong. Of course, all this is just speculation. We don't know what chemical reactions drive the metabolism of any potential life forms there, if they exist at all. We do not know which molecules play the role that DNA plays on Earth. But if the detected dimethyl sulfide is indeed being produced by biological organisms, it would mean that life there is not just possible, it's already adapted. And who knows, perhaps even now, in the warm depths of a distant ocean, creatures are slowly moving for whom our planet is as foreign and unreachable as their world is to us. Although K218b is currently considered the most promising candidate for extraterrestrial life, it's by no means the only one. Meet another fascinating planet, Tigodin b. It's located just 12.5 light-years away, by cosmic standards, practically next door. Scientists estimate that the chances of this planet having Earth-like conditions are about 60%. Moderate temperatures, possibly ranging from 0 to 50 degrees Celsius, liquid water, and a relatively stable climate. All of these could potentially be found on Tigodin b. However, and this is a crucial point, such conditions, if they exist, are likely only present in a narrow transitional zone between day and night. The reason is that the planet is most likely tidally locked. It always faces its star with the same side. This means one half of the planet is in perpetual daylight, while the other remains in eternal darkness. As a result, there are extreme temperature differences, from scorching heat to freezing cold. Exactly along the boundary between these two extreme worlds is a zone of eternal twilight. A moderate climate might be maintained here. Liquid water could exist, and therefore, so could life, possibly even complex multicellular organisms. Another intriguing planet where life might be found is Kepler 1649c. It was discovered in 2020 and lies 301 light-years away from Earth in the constellation Cygnus. Despite the distance, it has several features that make it particularly interesting to scientists. This planet orbits a small, dim star, a red dwarf that's about 5 times less massive than our Sun and 4 times smaller in size. Because of this, the planet receives about 25% as much light and heat as Earth does from the Sun. The planet itself is slightly larger than Earth, about 6% greater in radius and 20% more massive, so its gravity would feel fairly familiar, neither too strong nor too weak. However, like Tigodin b, Kepler 1649c likely has a major challenge to habitability. It's probably tidally locked as well. This situation could create extreme conditions. one side being too hot and the other freezing cold. Yet just like on Tigaden B, in the so-called twilight zone between the two sides, a stable climate with Earth-like temperatures and the presence of liquid water might exist. In this narrow strip between light and darkness, primitive life could potentially find refuge. TOI 700d is yet another intriguing candidate for habitability. This planet is located in the constellation Dorado, about 101 light-years from Earth, and was discovered in 2020. It's the third and outermost planet of the TOI 700 star system, and perhaps the most interesting one. Unlike Tigaden B and Kepler 1649c, which are likely tidally locked and always show one side to their star, TOI 700d may not have become tidally locked yet. Thanks to this, TOI 700d could still experience day and night cycles, resulting in a more stable and life-friendly climate. The planet receives about 86% of the light that Earth gets from the Sun, slightly less, but still enough. Its surface temperature, according to calculations, should be around -4 degrees Celsius. That's cool, but not extreme. And if the planet has even a modest greenhouse effect, conditions could be much milder. In terms of size, TOI 700d is just slightly larger than Earth. Its mass and radius are a bit greater, meaning gravity will be somewhat stronger, but still comfortable for potential life. There's another advantage. The star TOI 700 is relatively quiet. It doesn't produce powerful flares and storms that could destroy the planet's atmosphere, a rarity for red dwarfs, most of which are rather volatile. A calm star increases the chance of a long-lasting atmosphere, oceans, and possibly even life. Of course, we still can't say exactly what is happening on TOI 700d's surface, but more and more evidence suggests that it's confidently making its way onto the list of the most promising exoplanets we know of. However, not all potentially interesting planets resemble Earth. Some seem to have come straight out of science fiction, and J1407b is one of the strangest planets ever discovered by scientists. J1407b is one of the weirdest planets scientists have discovered. Located about 434 light-years from Earth, this is Saturn on steroids. Studying this eerie world, astronomers struggle to measure its mass precisely, but it's believed to be around 10 to 40 Jupiter masses. J1407b is also a giant planet, much larger than the biggest planet in our solar system. What shocked scientists was the planet's ring system of enormous size. It consists of 30 rings, each the size of tens of millions of kilometers in diameter. According to rough estimates, the diameter of the entire ring system is 120 million kilometers. This is 200 times larger than the rings around Saturn. If Saturn had its ring system this big, it would dominate our night sky. But although this would have been a breathtaking view, it wouldn't last long. The rings would eventually become thinner as several satellites would form around the planet. But that's just the beginning. The universe has stored a lot more bizarre worlds for us. How can one planet be hotter than the Sun, and another one larger than its star? How is there such a thing as a marshmallow planet? And what are planets? We prepared a list of the most mind-blowing worlds for you. One of them is an exoplanet located 57 light-years away from Earth, dubbed GJ504b. It's 4 times more massive, but is just about the same size as Jupiter. The weird thing about it is, it's pink, quite an unusual color for a planet. So how did it get this color? The system is believed to be roughly 160 million years old, a newborn compared to our solar system. And because of the exoplanet's age, it's still changing and losing the heat of its formation, which gives it a dull magenta glow. But our universe doesn't only come in electrifying colors. It also has a lot of water-rich planets. A Neptune-like exoplanet, or the water world, has a mass of more than 8 Earths and a radius 0.24 times that of Jupiter. And although this alien world may seem promising due to its abundance of water, it's no Earth twin. The planet doesn't have a solid surface, and its atmosphere drastically differs from the one we have here. Because of extreme pressure and heat, it consists of water in a strange plasma form that behaves differently from that found on Earth. Despite the fact that the temperatures there reach 280 degrees Celsius, water on GJ1214b doesn't have the usual vapor, liquid, and gas phases, but rather a constant supercritical fluid form. So it has some properties of both liquid and gas, but overall, it's neither and both all at once. Now let's move to the constellation Cygnus. There, about 650 light-years away, sits a scorching world, Kepler 70b. with a mass of just 0.44 Earths and a radius 0.75 times our planet. This is one of the hottest exoplanets known to us. The planet star Kepler-70 was once a main sequence star like our Sun, while Kepler-70b used to be a gas giant the size of Jupiter. But about 18.5 million years ago, the star went through its red giant stage. As a result of spending a significant amount of time inside its now-dead star, a hot iron core, the planet is all that's left. Scientists think the planet is still evaporating, which could eventually make it even smaller. So how hot is it? Because Kepler-70b is 65 times closer to its star than Mercury is to the Sun, the temperature on this exoplanet reaches a mind-blowing 6,650 degrees Celsius. To compare, our Sun's surface is only about 5,500 degrees Celsius. So, if hell exists, it must be it. About 640 light-years away from us sits yet another scorching exoplanet dubbed WASP-76b. But that's not the only thing the planet's known for. It also has a permanent dark side and molten iron rains. Discovered in 2016, it's nearly as massive as Jupiter. Since it's tidally locked to a star, the planet faces it at all times. The temperatures on the day side reach 2,350 degrees Celsius. This is more than enough to cause metals like iron to evaporate into the atmosphere. Additionally, the radiation that the day side receives is thousands of times more than our planet gets from the Sun. The dark side of WASP-76b is almost twice colder. Due to this extreme difference in temperatures, intense winds form on this exoplanet. Because of that, the iron vapor from the hotter part of the planet is carried by the wind to the colder side. And as this vapor cools, it rains molten iron. That's odd enough, but not as odd as a planet dubbed PSRJ 1719-1438b. But what's so impressive about it? This exoplanet is 3,000 times larger than its host neutron star. What's more, it wasn't always a planet. It used to be a star in the past. But let's start from the beginning. The exoplanet orbits an incredibly dense and tiny neutron star, about 20 kilometers across. Only 1 teaspoon of the star's material would weigh billions of tons on Earth. The star is also a millisecond pulsar that emits beams of radiation while spinning every 5.4 milliseconds. This is about 10,000 rotations per minute. The star isn't lonely. It has a companion planet about 40% the size of Jupiter. PSRJ 1719-1438b at the same time is more massive than Jupiter. So how come it's so small and yet so massive? This is because the exoplanet was once a star whose outer layers were stripped away by a much more massive nearby pulsar. This left a carbon remnant of a star that became a diamond world, about 5 times the size of our planet. It now has a diameter of roughly 60,000 kilometers. And because the exoplanet's proximity to the pulsar is very close, the whole system could fit within the diameter of our Sun. Space seems to be crowded with weird exoplanets, and some of them have properties so bizarre you could hardly believe these celestial bodies exist. Dubbed WASP-107b, this peculiar world has a density of cotton candy, which makes scientists revise their understanding of how gas giants form. While the exoplanet is about the same size as Jupiter, it's only 30 Earth masses, but Jupiter is 300 times as massive as our home planet. What's more, the core of WASP-107b is just 4 times bigger than the Earth's core, while it should be about 10 times that of our planet's. Because of all this, WASP-107b has an incredibly low density. In fact, it's like a marshmallow floating in space. So far, none of these worlds seem to be giving us any hope of colonizing them. But Gliese 581d could. Finding a planet that would be suitable for life is challenging in itself, and it becomes even more so because of how far away most of them are. That's why Gliese 581d looks so promising. It sits well within 20 light-years from Earth and has a mass just about 6 times the Earth's. The exoplanet is in a habitable zone of its star, so the temperature could be right for liquid water on its surface. However, because it's tidally locked, one side of Gliese 581d is always warmer than the other. But it's not all that bad. Since carbon dioxide is abundant in the planet's atmosphere, it would keep the night side from freezing. While the Earth has its own regular daylight cycle, and the majority of life forms here have adapted to live under such conditions, it's a big if the same could happen on Gliese 581d, given we colonize it one day. But if we do, the best idea would be to live in the region of habitability on the line that separates day and night, also called the Twilight Zone. The vastness of space is unimaginable, and 2-MASJ-2126 is living proof of that. This strange world was once thought to be a free-floating or lonely planet. But this celestial body isn't that lonely. It turns out that 2-MASJ-2126 moves through space along with a star, TYC 9486-927-1. The weird thing is, both objects have been known to astronomers for years, but nobody saw the link between them. But then, scientists discovered the exoplanet and the star both roughly 104 light-years from the Sun, which means they are connected. Later observations show the planet orbits its star at a distance of 1 trillion kilometers. This is roughly 7,000 times the distance from our planet to the Sun. This makes it the largest orbital radius of any planet known so far. Interestingly, a result of such a huge orbit is that a year on this exoplanet equals about 900,000 Earth years. Now, let's get back to our solar system for a moment. The biggest planet here has 79 moons, so it seems logical exoplanets should have exomoons too. But for years, scientists haven't been able to find any, until now. Locating small cosmic bodies orbiting exoplanets is extremely hard. Nevertheless, astronomers have finally succeeded. But they didn't spot an exomoon. They found something even better than that. The first ever clear evidence of a moon-forming disk surrounding a huge distant exoplanet named PDS-70c. With the help of the ALMA telescope in Chile, scientists detected a disk in which satellites could eventually form. And its material is enough to make 3 of them, each about the size of the Earth's moon. For the first time in the history of astronomy, human beings could be observing how these small round worlds form in space, and not on a computer simulation, but live. The last exoplanet on our list is KOI 5AB, and what makes this one specifically unique is not its properties, but the system it's a member of. The planet, about half the size of Saturn, was first ignored because it was complicated and even considered science fiction. A decade later, the system named KOI-5 was given the scientific attention it deserved. It turned out astronomers stumbled across a triple star system. The planet revolves around Star A, which is a relatively close companion, Star B. They both revolve around each other every 30 years. But there's also a third gravitationally bound star, Star C, and this one orbits stars A and B every 400 years. If we could somehow travel to this exoplanet and hover on the edge of this world's atmosphere with our spacecraft, we'd be seeing breathtaking and unusual things. The bottom view would be most probably filled with dark brown and gray clouds. And instead of one sun, you'd see 2, one 17 times bigger than our star, and the other one quite smaller and just about 0.5% as bright as our sun. But regardless of this, the faintest star would still glow 1,000 times brighter than the full moon here on Earth. No matter how unusual these alien planets are, there could be even stranger celestial bodies in our universe. So far, planets are usually hypothetical, but some scientists believe these could actually exist. If so, such mysterious worlds would form from the collisions of gas and dust particles surrounding black holes. These planets would also evolve at great distances from supermassive black holes, making their orbits million years long. The universe has no boundaries, not just in terms of distance, but also in terms of creativity. Now and then, astronomers discover mind-boggling space objects that broaden our limited imagination of the place we live in. It took us many years to discover all the planets of our solar system, and they are still surprising us with their properties. So who knows how much more eye-opening findings about the 5,000 known exoplanets are still ahead of us.